Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. This is a problem for exam P on probability. An insurer's medical reimbursements have density function f, where f of x is proportional to x times e to the minus x squared for x between 0 and 1 and 0 otherwise. Calculate the mode of the medical reimbursements. So please note that we know that the density is a certain constant times x times e to the minus x squared for the values of x between 0 and 1, and the density is 0 otherwise. The mode is the point where the density reaches a maximum. Obviously, the mode cannot happen anywhere but for x between 0 and 1. And since the density is proportional to this function x times e to the minus x squared, all we need to do is really find the value of x for which x times e to the minus x squared reaches a maximum if x is constrained to be between 0 and 1. So, again, we only need to find the value of x for x between 0 and 1, where x times e to the minus x squared reaches its maximum. Well, we note that x times e to the minus x squared equals 0 for x equal to 0, and it equals e to the negative 1, or approximately 0.367879441 when x is 1. The derivative of x times e to the minus x squared with respect to x is, well, derivative, it's a product of two functions, x and e to the minus x squared. So the derivative of x is 1 multiplied by the second term of the product, that's e to the minus x squared, plus the first term, x, multiplied by the derivative of e to the minus x squared, which is e to the minus x squared multiplied by the derivative of minus x squared, which is minus 2x. So this whole expression is, the derivative is equal to e to the minus x squared times 1 minus 2x squared. And of course, e to the minus x squared is positive. So the only time when this derivative is 0 is when the expression 1 minus 2x squared is 0. And we're looking for the point where the derivative is 0 because that's a likely candidate for the maximum of that function, for the point where the function reaches the maximum. Well, the derivative is 0 when 1 minus 2x squared is equal to 0. And of course that happens when x is equal to square root of 0.5, because it is equivalent to x squared equal to 1/2. So the derivative is positive when x is less than square root of 0.5, and negative when x is more than square root of 0.5. And therefore x times e to the minus x squared is a function of x first increases between x equal to 0 and x equal to square root of 0.5, and then decreases between square root of 0.5 and 1. And the derivative is 0 at x equal to square root of 0.5. And at that point, the expression x times e to the minus x squared equals approximately 0.428888194. Which, as you can see, is more than at one end of the interval from 0 to 1 and at the other end. And the function first increases, then decreases. So clearly that's where the maximum is. I'm doing this in all detail to absolutely make sure that that's the point where the maximum is reached. But you can actually you could have just found the point where the derivative is 0, and by looking at how this whole thing looks, you could have guessed the answer immediately then. So the answer is the square root of 0.5, which is approximately 0.707106781, or approximately 0.71. And that's answer C. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries and belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.